Sketch the region corresponding to the statement, the probability that z is between negative 1.7 and 1.4. In order to do this, what we first need to realize here is that this is asking for a probability between two values. So we need to change how we're shading on this chart. So we have options for the left, right, or between, or two regions. So we want between in this case. And that gives me two different sliders that I can adjust z-scores for. Now, I want the probability that z is between negative 1.7, so my lower z is going to be negative 1.7, and the upper z is going to be 1.4. So this shaded region in blue would be the total amount of area underneath the standard normal distribution curve between those two values. Sketch the region corresponding to the statement, the probability that z is less than c equals 0.3. Now, the first reaction that students often will have is to slide the z-score up to 0.3. But the thing is, in this particular question, what we want is the value of the shaded region, so the total area under the curve, to be 30%, not the z-score. So the difference here is, if you think about it, up from negative infinity up to 0, that's 50% of the distribution's area. So the z-score has to be somewhere below 0 in order to make 30% of the area, because it has to 30% is less than 50%. So what we have to do is we have to figure out what value corresponds with an area of 0.03 and then adjust to that particular z-score. Now, eyeballing where 30% is on the chart isn't quite so easy to do. So we would need to use some technology to help us out and determine where that z-score is going to be. But we can, however, adjust which direction we're shading. So you can either shade to the left, to the right, between two values, or outside of two values. But in this case, because we want z less than some z-score, we want to the left. So what I need to do then is to pull up my calculator, and I'm going to go to the inverse norm function. So if I hit second and vars, that brings up the distribution menu, and I can come down to INV norm. That's the third option for me. And it can take up to 3 inputs, but if you're looking for a z-score, you don't have to give the last two, which are a mean and standard deviation. They default to 0 and 1 for a standard normal distribution. The thing that you do need to make certain of is the input that you give is, however, area to the left of the value that you're interested in. So if you happen to have a problem where you need area to the right, you're going to have to make an adjustment to use the calculator. So if this was the probability that z was greater than c equals 0.3, you would have to actually do inverse norm of 0.7. Now, this gives me negative 0.524. So what I need to do then is adjust my slider to where my z-score is close to that value. And it's only accurate to 1 decimal. So what I will do then is just simply round to the first decimal, which is negative 0.5. And that will get me the correct answer for this particular problem. Now, when you were using the calculator, if you happen to have been given a menu when you went to second vars and inverse norm, that's perfectly acceptable. This is something that is a feature in the later model TI-84 calculators, where instead of having you remember what the input values are to all the different functions, it brings up a menu instead. The first input is area, which is area to the left, so we would put 0.3 here. Now, it does sort of require you to put all 3 inputs, even if you're on a standard normal, so Standard normal distribution has a mean of 0, standard deviation of 1, so make sure you put those in. Then when you hit paste, all it does is it feeds that information into the inverse norm function, so it operates in the same way. It's just helping you remember what those different inputs are.